At 09:45 hours on 28th of January 1943, the first prototype Bell XP-63 Kingcobra slammed into the frozen ground at Buffalo, New York. The landing gear had failed to extend. Test pilot Robert M. Stanley walked away from the wreckage. The aircraft, serial number 41-19511, had accumulated precisely 52 days of test flying since its maiden flight on 7th December 1942. It would never fly again. The second prototype followed 1 week later, on 5th of February 1943. During a routine test flight, the Allison 5 1710-47 engine seized without warning. The pilot had seconds to react. He chose the parachute. Serial number 41-19512 augured into the New York countryside, carrying with it months of engineering data and flight test results. 2 prototypes, 2 total losses, 8 weeks. Bell Aircraft Corporation had just destroyed the only 2 examples of what was supposed to be the salvation of their troubled P-39 Kingcobra program. The United States Army Air Forces had already ordered the aircraft into production 5 months before the first prototype ever left the ground, a vote of confidence that now seemed catastrophically premature. Production contracts called for hundreds of aircraft. The assembly lines at Niagara Falls were being retooled. Workers were being hired and trained, and Bell no longer possessed a single flyable example of the aircraft they were being paid to mass produce. This was not how fighter development was supposed to work. The P-63 Kingcobra emerged from a lineage of disappointment. Its predecessor, the P-39 Kingcobra, had entered service in 1941 as one of the most innovative fighters in the American arsenal. Mid-mounted engine, tricycle landing gear, a 37mm cannon firing through the propeller hub. On paper, it promised devastating firepower and revolutionary design. In practice, it delivered neither altitude performance nor competitive speed against German fighters. The decision to remove the turbo supercharger during development to save weight and reduce costs had gutted its high-altitude capability. Above 15,000 feet, the P-39 was a liability. By 1942, American pilots in Europe wanted nothing to do with it. The Royal Air Force had rejected it outright after brief trials. Only the Soviet Union, fighting a fundamentally different war at fundamentally different altitudes, found value in the design. The Soviets requested more. Bell engineers knew the P-39 had failed to meet expectations. They also knew why. The XP-39E experimental variant, first flown in February 1942, had attempted to address the fundamental problems. New laminar flow wings, improved engine installation, better aerodynamics. The aircraft reached 386 miles per hour at 21,600 feet during testing. It was faster than the standard Kingcobra. It was also inferior in nearly every other measurable way. The Army rejected it. But the Army was interested in the concept. Specifically, they wanted the laminar flow wing and the improved aerodynamics applied to a larger, more powerful aircraft. On 27 June 1941, before the XP-39E had even completed its test program, the Army issued a contract for 2 prototypes of an enlarged fighter designated XP-63. The specifications called for the same mid-engine configuration, the same 37mm cannon, and the same basic layout. Just bigger, just better. Just good enough to compete with the Focke-Wulf FW-190 and Messerschmitt Bf-109 that were shredding American bomber formations over Europe. The prototype that crashed in January 1943 had shown promise. The wingspan measured 38 feet 4 inches, length 32 feet 8 inches, empty weight 6,800 pounds. The Allison V1710-47 engine produced 1,325 horsepower. Top speed estimates suggested 410 miles per hour at 25,000 feet. Service ceiling 43,000 feet. Rate of climb 2,500 feet per minute. These numbers represented a genuine improvement over the P-39. The Army had liked what they saw. In September 1942, 3 months before the first prototype flew, they ordered the aircraft into production as the P-63A, Bell Model 33. The first production contract called for 1,725 aircraft. Additional orders would follow. Total projected production exceeded 3,000 units. The Bell factory at Niagara Falls began preparations for mass production immediately. Then both prototypes disintegrated within 8 weeks. Bell scrambled. A third prototype, serial number 42-78015, had been ordered in June 1942 as a testbed for the Rolls-Royce Merlin engine, the same power plant that made the P-51 Mustang the finest fighter in the American inventory. But Merlin production was committed entirely to Mustang production. Every available engine was going into P-51s. Bell couldn't have one even if they begged. So they installed another Allison instead, this time the V1710-93 variant. This engine featured a war emergency rating of 1,500 horsepower at sea level, making it the most powerful Allison variant yet fitted to an operational fighter. The third prototype, now designated XP-63A, first flew in April 1943. It immediately became the fastest Kingcobra Bell would build during the entire test program, achieving 421 miles per hour at 24,100 feet. The improved engine made the difference. So did the revised dorsal air scoop and modified exhaust configuration. The aircraft handled well. Test pilots reported no bad flying characteristics. It was genuinely better than the P-39 in virtually every measurable parameter. It was also genuinely inferior to the P-51 Mustang in virtually every parameter that mattered for the war the United States was actually fighting. The Army Air Forces conducted comparison trials through the summer and fall of 1943. The verdict came swiftly. The P-63 was not good enough. At high altitude, where American escort fighters needed to protect heavy bombers flying at 25,000 to 30,000 feet, the Kingcobra simply could not match the Mustang's performance. Its range was shorter, its speed at altitude was lower, its engine was less reliable. The laminar flow wing helped, but not enough. The second supercharger stage helped, but not enough. The Army had the Mustang. The Army had the P-47 Thunderbolt. The Army had the P-38 Lightning. The Army did not need the P-63 Kingcobra. In October 1943, the first production P-63A aircraft rolled off the assembly line at Niagara Falls. The Army took delivery. The Army declined to deploy them to combat units. The production line kept running. Over 1,600 workers at the Niagara Falls and Buffalo plants were building Kingcobras at the rate of 3 per day. Bell had contracts. Bell had commitments. Bell had nowhere to send the finished aircraft except into storage. The solution materialized from an unexpected direction. The Soviet Union needed fighters, desperately. The Eastern Front consumed aircraft at rates that exceeded Soviet production capacity. American Lend-Lease had already delivered thousands of P-39s, and Soviet pilots had learned to exploit the Aerocobra's strengths while accepting its limitations. At altitudes below 15,000 feet, where most Eastern Front combat occurred, the P-39 was competitive. Its 37mm cannon was devastating against German ground targets. Its rugged construction tolerated rough field conditions. Soviet pilots had racked up impressive kill counts flying American cast-offs that British and American pilots had rejected. The Soviets wanted the P-63. In February 1944, the Soviet government dispatched 2 representatives to the Bell factories in Buffalo and Niagara Falls. Test pilot Andrei Grigorievich Kochetkov was one of the most experienced aviators in the Soviet Air Force. Aviation engineer Fyodor Petrovich Suprun understood aircraft structures and flight dynamics at a level few Soviet engineers could match. Their mission was explicit: evaluate the P-63A production variant, identify problems, fix them before mass deliveries began. The Bell engineers initially ignored them. Soviet input was not welcome. The aircraft was already in production. The design was frozen. Changes would require expensive retooling and scheduled delays. The Americans had designed the aircraft. The Americans would deliver it as designed. The Soviets could take it or leave it. Kochetkov took it to the edge of its flight envelope and broke it. Spin testing began in March 1944. Standard procedure required exploring the aircraft's behavior in stalls and spins to identify recovery characteristics. Most fighters of the era could be coaxed out of a spin with proper control inputs. Some fighters had vicious spin characteristics that could kill an inexperienced pilot. The P-63, with its mid-mounted engine placing the center of gravity far aft of the wing, was going to be interesting. Kochetkov entered a deliberate spin at altitude. The aircraft rotated. He applied recovery inputs. The aircraft kept rotating. He increased control deflection. The aircraft entered a flat spin, nose high. Rotation accelerating. He applied full opposite rudder and forward stick. Nothing. The airframe began buckling under the aerodynamic loads. Metal panels flexed and popped. He held the controls at maximum deflection. The rotation continued. The ground grew closer. He had perhaps 3 seconds to make a decision. He pulled the canopy jettison handle and went over the side. The Kingcobra destroyed itself on impact. Kochetkov descended under a perfectly functioning parachute. He landed, rolled, stood up, and walked to the nearest telephone to call Bell. The aircraft had a fundamental spin recovery problem. Flat spins were unrecoverable. The pilot's only option was immediate bailout. This was not acceptable for a combat aircraft. If Soviet pilots lost situational awareness and entered a spin during low-altitude combat, they would die before they could get out. The Irving Parachute Company later sent Kochetkov a commendation for his professional test methodology and his unplanned but thorough field evaluation of their product. Bell could no longer ignore the Soviets. The problem was center of gravity. The mid-engine configuration placed most of the aircraft's mass behind the cockpit. When ammunition was expended from the forward firing guns, the center of gravity shifted further aft. In certain flight regimes, this created an aerodynamically unstable configuration that would enter a flat spin with no warning and no recovery. The only solution was to move the maximum aft center of gravity forward. This meant structural changes, reinforcement, additional weight, modifications to the ammunition storage, adjustments to the fuel system. Every change required engineering analysis, documentation, and factory floor implementation. Bell made the changes. Bell also sent P-63A-8, serial number 42-69261, to the Soviet Union for additional testing. The Soviets took it to TSAG, the Central Aerohydrodynamic Institute near Moscow, and put it in the largest wind tunnel in the world. Soviet aerodynamicists ran hundreds of test configurations. They documented flow separation patterns. They measured control surface effectiveness. They identified additional problems: wing covering deformation on the A-1, A-5, and A-6 production blocks, insufficient directional stability, inadequate pilot armor, limited external stores capability. Bell implemented every major Soviet recommendation. The A-5 variant received increased pilot armor and a fuselage hardpoint for bombs or external fuel tanks. The A-6 gained underwing hardpoints for additional external stores. The A-7 received a higher vertical tail and reinforced wings and fuselage. The A-9, the most significant modification, moved the 37mm cannon forward in the nose, improving center of gravity and increasing ammunition capacity from 30 rounds to 58 rounds. The Soviets even experimented with ski landing gear for winter operations, though this modification never entered production. The most visible change appeared on the P-63C production variant. A ventral fin was added beneath the rear fuselage to improve directional stability. This modification, suggested by Bell's own engineers after reviewing Soviet and NACA test data, became standard on all subsequent production aircraft. The P-63C also received the more powerful Allison 5 1710-117 engine, capable of 1,800 horsepower with water injection. Internal fuel capacity increased to 107 gallons. Protective armor weight increased to 201 pounds. The wingspan was slightly reduced. 1,227 P-63C aircraft were produced between January 1945 and the end of the war. The collaboration between Bell and the Soviet representatives transformed the Kingcobra from a marginal design into a genuinely capable aircraft, but only for the specific combat environment the Soviets faced. The P-63 remained a low-altitude fighter. Its engine delivered maximum power below 10,000 feet. Its wing loading and power-to-weight ratio favored tight-turning combat in the dense air near ground level. Its heavy cannon and provision for bombs made it effective against ground targets. For the air war over Germany, where American bomber escorts needed high-altitude performance and long range, the Kingcobra offered nothing. For the Eastern Front, where combat occurred between 300 and 3,000 meters, where German armor and infantry needed to be suppressed, where Soviet tactical doctrine emphasized close air support, the Kingcobra was nearly ideal. Delivery began in earnest in mid-1944. Women pilots of the American Women Air Force Service Pilots Program collected new Kingcobras at the Bell factory in Niagara Falls, New York. They flew them to Great Falls, Montana. From Great Falls, the aircraft continued north via the Northwest staging route through Canada to Fairbanks, Alaska, at Ladd Army Airfield in Fairbanks. United States Army Air Force's maintenance personnel serviced each aircraft and prepared it for Soviet inspection. Soviet inspectors examined every system, every control surface, Every instrument. Aircraft that passed inspection were accepted. Aircraft that failed were repaired until they passed. Soviet ferry pilots, many of them also women, took delivery at Nome, Alaska, and flew the aircraft west across the Bering Strait into Siberia. The route from Fairbanks to Krasnoyarsk measured 6,400 kilometers. The P-63's internal fuel capacity of 107 gallons was insufficient for the distances involved. So the route was divided into 5 segments with refueling stops at primitive airfields scattered across the Siberian wilderness. Temperatures routinely dropped below -40 degrees. Weather was unpredictable and often deadly. Navigation was by dead reckoning and visual landmarks in a region where charts were incomplete and magnetic variation was severe. Of the approximately 8,000 Lend-Lease aircraft delivered to the Soviet Union via the Alaska-Siberia route, 74 were lost in the United States, 58 crashed in Canada and Alaska, and 42 went down in Siberia. The P-63 loss rate was comparatively low. Out of 2,397 Kingcobras delivered to the Soviet Union, only 21 were lost en route. Soviet ferry pilots and maintenance crews had learned from years of experience moving P-39s along the same route. They knew the aircraft. They knew the weather. They knew how to survive. The official agreement between the United States and the Soviet Union specified that P-63 aircraft were to be reserved for operations against Japan in the Far East. The Soviets were explicitly prohibited from deploying Kingcobras against Germany. The reasoning was straightforward. The United States did not want American-manufactured fighters, carrying American markings, shot down over Germany and used for propaganda purposes. The Soviets agreed to the restriction. The Soviets ignored the restriction. Anecdotal evidence from both Soviet and German sources suggests that P-63s saw extensive combat on the Eastern Front from late 1944 onward. A Soviet pilot who served under legendary ace Alexander Ivanovich Pokrishkin reported in memoirs published in the 1990s that the entire 4th Guards Fighter Aviation Regiment secretly converted to P-63s in 1944, while officially remaining equipped with P-39s. German accounts corroborate this claim. Hans Ulrich Rudel, the most highly decorated Stuka pilot in the Luftwaffe, stated in his memoirs that over the Courland pocket in early 1945, German pilots frequently encountered American types of aircraft, especially Airacobras, Kingcobras and Bostons. German flak units reported shooting down aircraft identified as Kingcobras over Königsberg, Poland, and during the final assault on Berlin, official Soviet records show no P-63s in Europe. Every aircraft is documented as a P-39. The distinction is not subtle. The P-63 is noticeably larger, with different exhaust configuration and distinctive ventral fin on the C variant. Pilots and ground crews could easily distinguish between the two types. Yet Soviet after-action reports, victory claims, and loss reports meticulously identify every Bell fighter as a P-39. The paperwork maintained the fiction. The aircraft flying the missions did not. The reason for the subterfuge was simple. The Soviets needed every available fighter for the final push into Germany. The P-63 was available. The P-63 was superior to the P-39 in virtually every combat parameter. The P-63 had better armor, better armament, better performance, and better reliability. Soviet pilots who had experience on both types universally preferred the Kingcobra. Keeping the aircraft in the Far East to prepare for a hypothetical future conflict with Japan while German forces were still defending Berlin made no strategic sense. So the aircraft went west. The documents went into archives marked P-39. The Americans either did not know or chose not to ask difficult questions. The Soviet Air Force developed specific tactics for the Bell mid-engine fighters. The 37mm cannon was devastating but slow firing. Rate of fire was approximately 2 rounds per second. Ammunition capacity on the P-63A-9 was 58 rounds. This meant approximately 30 seconds of firing time. Soviet pilots learned to fire in short bursts of 1 to 3 rounds. 1 round was sufficient to destroy most German aircraft if it connected. The weight of the shell, combined with the explosive filler, meant that a single hit to wing root or fuselage would cause catastrophic structural failure. German pilots learned to fear the distinctive muzzle flash of the 37mm firing through the propeller hub. The 4 Browning M2 machine guns, 2 in the nose and 2 in underwing gondolas, provided sustained fire for ranging and target suppression. Soviet pilots typically removed the underwing gun pods to reduce weight and drag. The two nose-mounted guns, synchronized to fire through the propeller arc, were retained and provided adequate additional firepower for most targets. Some Soviet units replaced the American guns entirely with Soviet UBS 12.7 mm machine guns and Soviet cannon of various types. The modifications were not officially approved but were widespread in frontline units. The heated cockpit and effective radios made the P-63 popular with Soviet pilots who had previously flown open cockpit fighters like the Polikarpov Farn-16. The tricycle landing gear made ground handling easier and reduced landing accidents. The rugged construction tolerated rough field conditions and heavy combat damage. Soviet maintenance crews appreciated the relatively simple engine and systems. Spare parts flowed through the Lend-Lease pipeline with reasonable reliability. Aircraft that were damaged but repairable could be returned to service quickly. Combat effectiveness was difficult to quantify. Official Soviet histories downplayed the role of Lend-Lease aircraft in favor of domestic designs like the Yak-9 and La-5FN. Victory claims often did not specify aircraft type. Many Soviet aces flew multiple aircraft types during their careers and accumulated victories on whatever was available. But the evidence suggests the P-63 was successful. Soviet units equipped with Kingcobras achieved favorable exchange ratios against German fighters. The aircraft proved particularly effective against Junkers, Ju-87 Stukas, and German medium bombers. It was also used extensively for ground attack, carrying up to 1,500 pounds of bombs or rockets on external hardpoints. The low-altitude performance was the key. Most Eastern Front aerial combat occurred between 1,000 and 5,000 meters. The Allison engine in the P-63 produced maximum power at sea level and maintained good performance up to approximately 4,000 meters above that altitude. Power dropped off rapidly. For comparison, the Rolls-Royce Merlin engine in the P-51 Mustang was optimized for high-altitude performance and produced peak power above 6,000 meters. The Merlin was the wrong engine for low-altitude combat. The Allison was the wrong engine for high-altitude combat. The Germans fought at low altitude in the east and high altitude in the west. The Soviets got the right engine for their war. The P-63 also had an impressive roll rate. At 275 miles per hour, the Kingcobra could roll at 110 degrees per second. This exceeded the roll rate of the P-47 Thunderbolt, P-40 Warhawk, P-51 Mustang, and the Japanese Kawanishi N-1K2 Shiden Kai fighter. In low-altitude turning combat, the ability to rapidly reverse direction was critical. Soviet pilots exploited this advantage aggressively. German pilots who attempted to reverse and disengage often found a Kingcobra rolling into firing position before they could complete the maneuver. When the Soviet Union finally declared war on Japan on 9 August 1945, P-63 units deployed to the Far East had been preparing for months. The brief but intense campaign against Japanese forces in Manchuria and northern Korea demonstrated the aircraft's capabilities in the role for which it had been officially intended. Kingcobras provided fighter escort for Il-4 bombers, conducting strikes against Japanese fortifications. They flew close air support missions for advancing Soviet ground forces. They conducted reconnaissance and strafing attacks against Japanese airfields and supply lines. On 15 August 1945, Junior Lieutenant I.F. Miroshnichenko of the 17th IAP, part of the 190th IAD, engaged two Japanese fighters attacking Soviet transport aircraft near the coast of North Korea. Flying a P-63, Miroshnichenko shot down one Japanese aircraft, identified as a Nakajima Ki-43 Hayabusa. This was the first confirmed air-to-air victory for a Soviet P-63. The second Japanese fighter escaped at low altitude. The entire engagement lasted less than 2 minutes. One burst from the 37mm cannon was sufficient. Soviet P-63s also supported the invasion of the Kuril Islands. The 888th and 410th IAPs from the Kamchatka Peninsula conducted strikes against Japanese positions on the islands, then provided air cover for the amphibious landings. Japanese air opposition was minimal. Most Japanese fighters in the region had been withdrawn to defend the home islands or had been destroyed in earlier combat. The P-63 pilots found their primary targets were ground installations and shipping. By 9 May 1945, when Germany surrendered, operational Soviet units still had 1,148 Kingcobras on strength. These aircraft remained in service for years after the war. The Soviet Air Force continued operating P-63s well into the early 1950s. The tricycle landing gear made them useful for training pilots transitioning to jet aircraft like the MiG-15, which also used tricycle gear. Soviet pilots who had flown tailwheel fighters their entire careers needed to learn new landing techniques. The P-63 provided the training without consuming scarce jet fuel or risking expensive jet fighters. The aircraft was eventually given the NATO reporting name Fred when it appeared in post-war Soviet service. American intelligence analysts tracked Soviet P-63 units through the late 1940s. By 1950, most had been retired or relegated to training roles. On 8 October 1950, two United States Air Force F-80C fighters from the 49th Fighter Group breached Soviet airspace and attacked Sukhaya Rechka airfield, 19 miles southwest of Vladivostok. The attack, later claimed to be a navigation error, caught Soviet forces by surprise. The airfield belonged to the 821st Fighter Aviation Regiment of the 190th Fighter Aviation Division. 12 P-63s were damaged in the strafing runs. One burned to the ground. The others were repaired and returned to service. No Soviet personnel were killed. This was one of the last recorded combat encounters involving P-63s. The aircraft had fought in 2 wars, served 2 powers that were not on speaking terms, and survived to become a footnote in a conflict that would define the next 40 years. The story of American service was different. The United States Army Air Forces never deployed P-63s to combat zones. Small numbers were assigned to advanced training units where they served briefly before being withdrawn and placed in storage. Most sat in desert storage facilities, slowly deteriorating in the sun. Some were eventually scrapped. Others found new lives in ways their designers never imagined. The most unusual American use of the P-63 was Operation Pinball, one of the strangest training programs ever devised by any military service in any war. The problem was simple. American bomber crews were being slaughtered over Europe. Luftwaffe fighters attacked in coordinated waves. German pilots had years of combat experience. American gunners, fresh from training schools, had never fired at a real aircraft making a real attack at combat speeds. Towed targets were inadequate. They flew straight and level. They were slow. They did not maneuver. They taught gunners to track predictable targets in ideal conditions. They did not teach gunners to hit a Focke-Wulf 190 coming in at 400 miles per hour in a steep diving attack with guns firing. The solution was to let gunners shoot at real fighters making real attack runs, with real pilots inside them, with real bullets. The concept emerged in 1942. Development took 2 years. By May 1944, Operation Pinball was operational. The aircraft selected was the P-63. It was available. It was large enough to carry the required armor. It was fast enough to simulate German fighter attacks. It was agile enough to make realistic gunnery passes. Most importantly, the Army did not need it for anything else. 332 P-63s were converted to RP-63 configuration for Operation Pinball. All armament was removed. The 37mm cannon, the machine guns, the ammunition, all deleted. In their place, over 1 ton of armor plating was installed. The armor was not the standard aircraft armor used to protect pilots. This was special duralumin alloy sheet, thickness varying from 1/8 inch to 1/4 inch depending on location. The thickest armor covered the cockpit. Additional armor protected the engine, fuel system, and control runs. The windscreen and canopy side panels were replaced with armored glass. Steel grills covered the air intakes. Steel guards protected the exhaust stacks. The propeller blades were hollow and thick-walled to resist bullet strikes. The armor added 1,500 pounds to the aircraft's empty weight. This degraded performance significantly. Takeoff runs were longer. Rate of climb was reduced. Maximum speed dropped. Engine cooling became marginal. Pilots had to manage power carefully to avoid overheating. The aircraft was less maneuverable and less responsive. Flying an RP-63 required constant attention to engine temperatures, oil pressure, and control inputs. The aircraft were painted bright orange for visibility. The distinctive color earned them the unofficial nickname Pinball, but the name came from something else. Impact sensors were installed throughout the armor. When a bullet struck the aircraft, the sensor detected the impact and sent an electrical impulse to lights mounted in the nose and wingtips. The lights flashed. The aircraft lit up like a pinball machine. Bomber gunners could see immediately whether they had scored hits. Pinball pilots could see how badly they were getting shot. The bullets were special too. Standard .30 caliber ball ammunition would have killed pinball pilots, no matter how much armor they wore. The armor was designed to stop rifle caliber projectiles, not sustain machine gun fire. So engineers at Duke University and the Bakelite Corporation developed frangible rounds. These projectiles were made from a mixture of lead and Bakelite plastic. They were strong enough to be fired from standard Browning machine guns at normal velocities. They would fly straight. They would hit hard enough to register on the impact sensors. But when they struck aluminum or steel, they disintegrated. They did not penetrate. They did not ricochet. They shattered into dust. The rounds were designated cartridge caliber .30, frangible ball M22. By August 1945, production had reached 40 to 45 million rounds per month. Bomber gunnery schools consumed them by the tens of millions. The cost was enormous. The training value was immeasurable. Operation Pinball missions followed standard profiles. A bomber, typically a B-17 Flying Fortress or B-25 Mitchell, would take off with a student gunner at each defensive position. The RP-63 would take off separately and climb to altitude. Once both aircraft were in position in the designated training area, the pinball would make repeated attack runs from various angles and speeds. Head-on, tail chase, beam attacks, high side, low side. The student gunners would track the attacking fighter and fire when they had a solution. The pinball pilot would maintain the attack profile, watching the lights flash as bullets struck his armor. After each pass, he would break away, set up for the next run, and do it again. The pilots who flew these missions were either exceptionally brave or exceptionally crazy. Most fell somewhere in between. They flew directly into streams of machine gun fire from multiple turrets on each pass. The bullets were frangible, but frangible rounds fired at close range still carried significant kinetic energy. If a round found a gap in the armor, if it struck an air intake at exactly the wrong angle, if it hit an unprotected control cable or hydraulic line, the results could be catastrophic. Multiple RP-63s were shot down during Operation Pinball missions. Some pilots were killed. Others bailed out successfully. All accepted the risk as part of the job. One pinball pilot, frustrated by a particularly poor student gunner who could not hit him despite multiple passes, flew up alongside the bomber and radioed the gunner asking if he could hit him now. The gunner could. The bomber's defensive guns shredded the RP-63 from the side where the armor was thinnest. Bullets penetrated the cockpit area. The pilot broke off immediately, smoking and trailing coolant. He made an emergency landing at the nearest airfield. He never made himself an easy target again. Another pilot returned from a mission to find that a lucky shot had penetrated an air intake and severed a coolant line. The engine had been running on residual coolant for the last 10 minutes of flight. If the mission had lasted 30 seconds longer, he would have seized the engine and gone down. By the end of the war, Operation Pinball had trained hundreds of bomber crews. Gunners who had fired at RP-63s performed demonstrably better in combat than gunners who had only trained on towed targets. Loss rates for bombers with pinball-trained gunners were measurably lower. The program worked. It was expensive. It was dangerous. It consumed aircraft and ammunition at staggering rates, but it saved lives. After the war ended, the surviving RP-63s were redesignated QF-63 and placed in storage. Most were eventually scrapped. A handful survive in museums, painted in the bright orange scheme that once made them visible targets in the skies over Texas, Arizona, and Florida. France received 300 P-63s in 1945. Arriving too late to see combat in World War II, French units deployed them to Indochina in 1949, where they saw limited combat before being replaced by more modern American types in 1951. The aircraft proved adequate for colonial warfare, but was increasingly obsolete against any competent opposition. Honduras operated P-63s for a time in the post-war period. A few other nations evaluated the type but did not place orders. The market for mid-engine fighters with marginal high-altitude performance had closed. The jet age was beginning. Piston fighters, regardless of capability, were being retired as fast as jets could replace them. Total production of P-63. Kingcobras reached 3,303 aircraft. Bell produced 1,725 P-63As between October 1943 and December 1944. 1,227 P-63Cs followed between January and December 1945. The P-63D, with a bubble canopy and longer wingspan, remained a single prototype. The P-63E, similar to the D but with conventional canopy, produced only 13 examples before the war ended and contracts were canceled. Two P-63F aircraft, featuring an enlarged vertical tail, were completed before production ceased entirely. The aircraft cost American taxpayers $48,000 per unit. That figure included airframe, engine, instruments, radios, guns, and government-furnished equipment. It did not include research and development costs, factory tooling, or the extensive modifications demanded by Soviet representatives. The total program cost exceeded $150 million. For that investment, the United States obtained an aircraft it did not use and transferred to an ally it did not entirely trust. The strategic value of that transfer is difficult to calculate. The Soviet Union needed every available fighter in 1944 and 1945. The P-63 provided capability that exceeded Soviet domestic production in several key parameters. Soviet pilots appreciated the aircraft. Soviet mechanics could maintain it. Soviet logistics could support it. Whether those aircraft shortened the war or reduced Soviet casualties is unknowable. The aircraft were there. They were used. They performed adequately in roles for which they were never designed and in a theater where American planners never intended them to serve. The P-63 represented a fundamental mismatch between American requirements and Soviet requirements. American doctrine in Europe required high-altitude escort fighters with long range. Soviet doctrine on the Eastern Front required low-altitude ground attack aircraft with heavy armament. The P-63 could not do what the Americans needed. It could do what the Soviets needed. The Lend-Lease program facilitated the transfer. Both nations benefited. The Americans cleared production lines for aircraft they actually wanted. The Soviets received aircraft they could actually use. The collaboration between Bell engineers and Soviet representatives demonstrated what could be accomplished when both sides had incentives to cooperate. The Soviets needed a better aircraft. Bell needed a customer. The resulting modifications made the P-63 significantly more capable than the original design. Soviet test pilots identified problems American test pilots had missed or downplayed. Soviet engineers suggested solutions American engineers had not considered. The final production variants incorporated improvements that came directly from combat feedback and rigorous testing in conditions American test facilities could not duplicate. This cooperation occurred during a period when the United States and Soviet Union were allies only in the narrow sense of fighting a common enemy. Trust was minimal. Information sharing was carefully controlled. Technology transfer was scrutinized. Yet the P-63 program worked because both sides needed it to work. Bell got paid. The Soviets got aircraft. American bomber crews over Germany did not face P-63s being flown by German pilots. Everyone won except perhaps the Germans being shot at by them. The fate of individual P-63s after the war varied widely. Most Soviet aircraft were eventually scrapped or converted to other uses. A few survive in Russian museums. Serial number 42-68609, recovered from the Kuril Islands in 1998, is on static display at the Military Aviation Museum in Virginia Beach. Several examples were converted to air racers in the post-war United States. These heavily modified aircraft competed at unlimited races through the 1940s and 50s. Most were eventually destroyed in accidents. The combination of high power, marginal cooling, and aging airframes proved lethal. Tipsy miss. A clipped wing racer painted bright orange, white, and black was destroyed in a crash in 1990 in Europe. Crazy Horse Campgrounds, the most radically modified P-63 ever built, featuring a tiny bubble canopy and extreme aerodynamic modifications, crashed in 1990, killing the pilot. Today, approximately a dozen P-63s survive worldwide. Most are static museum displays. 2 or 3 are maintained in airworthy condition by private collectors and warbird organizations. They appear occasionally at air shows where crowds gather to watch aircraft that were too good for the Americans and just good enough for the Soviets. The sound is distinctive. The Allison engine has a different note than the Merlin or the Pratt & Whitney radials. The mid-engine configuration gives the aircraft a unique profile. It does not look like a Mustang or a Thunderbolt or a Corsair. It looks like what it is, a Bell fighter. Unconventional, unappreciated in its homeland, successful elsewhere. The legacy of the P-63 Kingcobra is not found in American histories of World War II. It appears in footnotes and sidebars. It is the aircraft American museums display with a small placard explaining that it served with Soviet forces. The significance is acknowledged but not explored. The details are left vague. Official American histories focus on the Mustang, the Thunderbolt, the Lightning. These were the aircraft that won the air war over Europe. These were the aircraft that American pilots flew to glory. The Soviet histories are more complicated. The aircraft was always called the Cobra, never Kingcobra. It was mixed in after action reports with the P-39 so thoroughly that separating the two types decades later became impossible. Soviet pilots knew the difference. Soviet records obscured it. The political necessity of minimizing Lend-Lease contributions during the Cold War meant that American-supplied aircraft were downplayed or ignored entirely in official histories published after 1946. The aircraft that Soviet pilots praised in letters home became the aircraft Soviet historians forgot to mention. In the Russian Federation today, the history is being slowly recovered. Veterans of the Great Patriotic War who flew the Cobra speak openly about what the aircraft meant to them. Museum displays acknowledge the American origin. Historical articles examine the Lend-Lease program more honestly than Soviet propaganda ever allowed. The P-63 is being restored to its proper place in the history of the Eastern Front. The irony is unmistakable. The United States designed and built an excellent low-altitude fighter for a war it was not fighting. The Soviet Union accepted that fighter and used it to fight a war where low-altitude performance mattered more than anything else. Both nations benefited from this accident of strategic mismatch. The Americans cleared factory space for aircraft they needed. The Soviets received aircraft that met their needs precisely. No one planned this outcome. It simply happened because industrial capacity, strategic necessity, and political expedience aligned at exactly the right moment. The P-63 Kingcobra was obsolete before it entered service. Its design philosophy belonged to the late 1930s when tactical fighters operated at low altitude and fought for air superiority over the battlefield. By 1943, the air war in Europe had moved to 20,000 feet and above. Escort fighters needed range and high-altitude performance. The Kingcobra had neither, but the Eastern Front in 1944 resembled the Western Front in 1940. Low altitude, short range, ground attack. The obsolete American fighter was exactly what the Soviets needed, because the war they were fighting was the war the aircraft had been designed for 5 years earlier. Military history is filled with weapons that arrived too late, performed poorly, or were deployed to the wrong conflict. The P-63 reversed the pattern. It was the right weapon for the wrong war. Then it was transferred to the right war. The aircraft failed in American service, not because it was poorly designed, but because American requirements had evolved beyond its capabilities. The aircraft succeeded in Soviet service not because Soviet pilots were better, but because Soviet requirements matched what the aircraft could deliver. The men who flew the P-63 understood this better than the generals who ordered it and the politicians who paid for it. American test pilots who evaluated the aircraft reported that it was pleasant to fly, adequately armed, and capable of acceptable performance at low altitude. They also reported that it could not compete with German fighters at high altitude and lacked the range for escort missions. Soviet pilots reported that it was fast at low altitude, heavily armed, and rugged enough for frontline service. They used it to shoot down German aircraft and strafe German positions. Both assessments were correct. The aircraft was exactly what it was designed to be, a mid-engine tactical fighter optimized for low-altitude combat. The P-63 Kingcobra never became famous. It never achieved the iconic status of the Spitfire or Mustang. It never accumulated the combat record of the Yak-9 or La-7. It served quietly in a war where quiet service was the norm and individual glory was subsumed into collective victory. Soviet pilots flew it because it was available and it worked. American training pilots flew armored versions because someone had to teach bomber gunners how to shoot. French pilots flew it in colonial wars because newer aircraft had not yet arrived. Honduran pilots flew it because their air force could not afford anything better. 75 years after the last Kingcobra rolled off the production line, the few survivors sit in museums or appear briefly at air shows. The crowds photograph them. The announcers explain their history. The volunteers polish the aluminum and maintain the engine. The aircraft starts. The engine roars. The fighter taxis and takes off. It climbs. It maneuvers. It demonstrates what it was built to do 75 years ago in a war that killed 80 million people and reshaped the world. Then it lands. The engine shuts down. The pilot climbs out. The aircraft is pushed back into the hangar. The crowds go home. The fighter waits for the next show, the next flight, the next brief moment when history becomes visible and audible and real. The story of the Bell P-63. Kingcobra is not about glory or heroism or decisive battles. It is about industrial production meeting strategic necessity. It is about international cooperation during wartime. It is about an aircraft that nobody wanted becoming an aircraft that somebody needed. It is about the gap between design requirements and operational reality. It is about compromise and adaptation and making do with what was available. The men who built it did their jobs. The men who tested it did theirs. The men who flew it did theirs. The aircraft performed exactly as designed in roles it was never intended to fill. Some aircraft become legends. The P-63 Kingcobra became a footnote. That footnote, examined closely, reveals something true about how wars are actually fought and how victory is actually achieved. Not through brilliant designs or inspired leadership or heroic sacrifice alone, but through logistics and production and getting adequate equipment to the people who need it when they need it. The P-63 was adequate. In VAR, adequate is sometimes enough.